Alright, so now we're going to be talking about relative motion in 2 dimensions, and it's pretty similar to 1 dimensions with some key differences. So again, we're going to look at an example. So if we could think about like something moving this way, okay, let's say we have something moving this way at 4 meters per second. Well, it's going to keep going that way 4 meters per second. Let's say this is relative to the Earth. Okay? But also let's say now that it's moving 4 meters per second relative to the Earth, but maybe it's a boat and there's a current pushing it this way at, say, 3 meters per second. So normally the boat would be going 4 meters per second, and it's going actually not relative to the Earth, but 4 meters per second relative to the water. And now it's getting pushed this way at a rate of 3 meters per second. So it's not going this way, it's actually going that way. Okay, so I'm going to give you a little illustration of this. Okay, and so here we have this picture of a boat, and let's make it go 4 meters per second. Okay, and so let's just go ahead and watch it go across the river. There we go. Boat going across the river. Right? Not too bad. Now, what we're going to do this time, though, is we're going to give the river a velocity. Okay, the river's going to go 4 meters per, or 3 meters per second, we said. Okay, so what this means is we have here this velocity of the boat relative to the river going 4 meters per second. We have this velocity of the river relative to the Earth going this way at 3 meters per second. And so the velocity of the boat relative to like someone standing on the shore is going to be 5 meters per second. Okay, and so let's go ahead and run it and see. Because the boat is getting carried this way by the current. Okay, and so it's actually going faster because it's getting to the same it's going the same, taking the same amount of time. Okay, but instead of ending up here, it ended up here. So it had a greater displacement, so it's going faster. Okay, so let's watch it again. With 0 velocity for the river, it goes straight across, 4 meters per second. We give the river some velocity. Now it's going further in that same amount of time. Okay, and so we have a greater velocity here, okay, relative to the Earth. Now the person in the boat feels like they're still going 4 meters per second. Okay, they're looking at the water and they're going past the water at a rate of 4 meters per second. Okay, but to the person standing here on shore, they're going 5 meters per second. Okay, and we'll do one more example of this. And so what we'll say is this. We have, let's say that we have a person in a swimming pool. Okay, or let's say they're in a river. Okay, and the river's going like this. Okay, and let's say that they can swim about 2 miles per hour. And that might, I don't know if that's fast or not. Let's say that's how fast somebody swims. And so they're going about 2 miles per hour. Actually, let's change this to 1 meter per second. So we're going 1 meter per second this way. Okay, across the river. And pretty standard, they leave. And so this person standing right here is watching them swim. They're like, oh look, you're swimming 1 meter per second, and you're going to swim across the river. Okay, and they end up like right here. But let's say now the river, it's actually a river that flows like all other rivers, and so it has a current this way of 0.5 meters per second. Okay, well, this person is still swimming 1 meter per second this way, but now the current is carrying them 0.5 meters this way every second. And so person here on the shore sees, oh look, they're going this way at a faster speed than 1 meter per second, but this person just feels like they're going 1 meter per second that way. But then when they look up, they're going to see this spot on the shore drifting past them, and they're going to end up somewhere over here. Okay, so we could figure out how fast they're going relative to the shore by adding these. Okay, if we had different angles, we'd have to break them into components. We just have these single components, so it's a little easier. We can do Pythagorean Theorem. So 1 squared plus 0.5 squared take the square root of that and get something like take the square root and get like 1.12 meters per second. Okay, and so this person feels like they're going, they feel like they're going the same speed, but looking at the short, it looks like they're going a little faster. This person here sees them going faster than they normally would. Okay, and this is really what it is. It's kind of confusing and it's kind of hard, but it's really, at the end of the day, the concept is really simple. It's just difficult to grasp. Okay, so this is 2D relative motion.